Okay, the last section that we covered in Chapter 11 was the third section, which involved radical equations. So basically, this is just going to outline extra practice for you for this coming up Thursday. So I'm going to basically go through one of the quizzes that we had, specifically the second form I gave out, Form B. Basically, I'm going to go through all these problems as example problems. I encourage you to try them out yourself and then see what happens after that. So first things first, I am going to start off with this one. They progressively got more difficult as they went down the page. So the first one is root x plus 1 equals 4. Your first step whenever doing these is to isolate the radical first. In this case, I've got the radical on one side. I'm good to go. It's only the radical on the one side. That means I can square both sides because it's a square root. So root x plus 1, when I square it, I'm just left with x plus 1. 4 squared gives me 16. I'm going to subtract 1 over. I get x is equal to 15. And that's my answer. Okay. You could plug 15 in work to see if it works. 15 plus 1 is 16. The square root of 16 is 4, which equals 4. We're good to go. So that's the first one. Second one, this was a very, very commonly missed one. 5 root x equals x. Whenever you have a number times the radical, there's two ways you can do this, okay? Since I don't have a plus or minus on the left-hand side, the radical is technically isolated already. So the first way is you can square it first, okay? That's acceptable. So what do you get? 5 root x times 5 root x, that is very ugly, square root. 5 root x times 5 root x is, take the numbers, you multiply them, and then square root of x times square root of x gives you x. Okay, so this is 25x equals x squared. A lot of people divided by the 25x, and that gives you one of the answers, but you're missing one in the end. Your goal is to not divide by x. Okay, what I'm going to do, I'm going to take this whole term and move it to the other side. Okay, so I'm going to subtract 25x from both sides. Okay. That gives me 0 equals x squared minus 25x. Now I'm going to take out a GCF. I can factor this, right? I could take out an x. I get x minus 25 times x. Setting both of those factors equal to 0, I get x equals 0 and x equals 25. Okay. Both of these end up working. So 0 works. Okay. 0, the square root of 0 is 0, times 5 is 0. So 0 equals 0 is fantastic. 25, let's see what happens when I plug that in. 25, the square root of 25 is 5, times 5 is 25, and that's equal to 25. So they both work. There's no extraneous solution here. So that was a commonly missed one. You're going to want to square both sides, which the 5 will also be squared. And then you'll want to make sure that you don't divide by anything. You're just going to subtract stuff over because you're going to get extraneous stuff because you're dividing by x. So that was one of them. Another one. Let's start off with this one. Root 3x plus 4 equals root 4x minus 6. In fact, if you can solve a linear equation, this one is just as easy. It just looks more complicated. Whenever you have a square root and a square root on both sides and there's nothing else with it, you can just set the insides equal to each other. Or, I mean, if you square both sides, then in essence, it's just going to get rid of the square root. So if I'm getting rid of the square root on both sides, I'm left with 3x plus 4 equals 4x minus 6. Two ways I can do this. I'm going to subtract 3x first. So I get 4 equals x minus 6. Then I can add 6 on both sides. Gives me x equals 10. Okay. Another way, you could have just subtracted the 4x over instead, but it doesn't really matter. So x equals 10. And when you plug that in, you get 34 under the square root on the left-hand side, and then you get 34 under the square root. They're both the same thing. So x equals 10 works. Okay. Let's do this one. X minus 3 to the 1/2 minus 3 equals 8. Okay. First step, isolate the radical. I saw a lot of people square it first when you have this minus 3 here, and that can't work. So I need to add the 3 first on both sides. That gives me the radical isolated. Okay, 8 plus 3 gives me the 11. Now I'm able to square both sides because I'm raising it to the 1/2 power, giving me x minus 3 equals 121. Adding the 3 gives me 124. Okay, so the reason why this one was thrown on there is because this minus 3 was going to be an issue. You needed to move that over first before you could square. All right, next one, I got root x plus 1 equals x minus 10. There's probably going to be a problem that's like this coming up on Thursday. Okay, this is requiring you to be able to FOIL out and solve a quadratic, even if it might be more complicated. Okay, so x plus 1 is the radical, and that is by itself. So what I'm going to do is I'm going to square both sides now. So if I square the left and I square the right, a very common thing was this is not the same as x squared plus 100. That's not the same thing. Or minus 100, not the same thing. Okay, so making sure you FOIL out your binomials is very important. So I got x plus 1 on the left. On the right, this is x minus 10 times x minus 10. Okay. The right-hand side goes to x squared minus 20x plus 100. I'm going to subtract over x and the 1. Okay, a lot of people just put a minus in front of the x and they added 1 on both sides, giving them the wrong answer. I'm going to subtract 1 also. So minus x minus 1. Okay, this is 0 on the left. Right hand side ends up being x squared minus 21x plus 99. Now this is actually just a quadratic formula problem. Okay, I'm going to get rid of this up here. You've got a quadratic that you can't factor. Some people ended up changing this into something that they could factor by like making the numbers something they weren't supposed to be. So this is what you're supposed to have. You can quadratic formula from there. I'm gonna put it up here so I can write out the formula. Okay. It's important to remember that formula if you don't have it memorized already. The formula is x equals negative b, in this case b is negative 21, so 21 plus or minus the square root negative 21 squared minus 4 times 1 times 99 all over 2. Honestly, if you just kept it like that, I would have probably have given you full credit, okay? But the issue is there is one solution that doesn't work. So when you end up, you could approximate these to a decimal. That's perfectly fine for it being able to check your work, okay? You get 2 answers from this. You get 13.8 roughly and 7.1 roughly. Okay? If you plug these back into your equation, only this one makes sense. Okay, so this one doesn't. So technically, if you put both of them, you would only receive, you would get minus 0.5 point because there was one that was extraneous, but this work is important to get. Okay, so plugging it into the quadratic formula correctly is a really, really good step for you to where you'll pretty much get the entire question right. So that's one to make sure you look out for, is something like that where you have to square a binomial. Probably going to ask something like that. Okay, this next one, same thing. I'm going to be squaring a binomial in this one. This one's a little easier though. So I have x plus 7 to the 1/2 minus 1 equals x. The radical is not isolated. Isolate it first. Get rid of that 1. You're going to add 1 on both sides. I had some people subtract 1. Make sure you know how to undo your operations on each side, okay? If I have a minus 1, I'm going to add 1, okay? This is going to give me x plus 7 to the 1/2 equals x plus 1. I'm going to square both sides now. Notice this is not the same as x squared plus 1 on the right, okay? You have to FOIL it. X plus 7 equals, this is going to be x plus 1 times x plus 1. Okay. Left-hand side's fine. The right-hand side is x squared plus 2x plus 1. That's what that multiplies out to. I'm going to subtract x and subtract 7 from both sides. Minus x minus 7. giving me that 0 equals x squared plus x minus 6. This factors. Oh, I just erased it all. Okay. This factors. In fact, very nicely. Moving up to the top over here. Factors of negative 6 that add up to 1. Okay. Well, that goes to x plus 3, x minus 2. Okay, setting those both equal to 0, I get x equals negative 3 and 2. In fact, only 2 works in this. So you'll plug both of them back in. You'll see that negative 3 doesn't work. 2 is the only one that works. Okay. Remember, factoring or foiling the x plus 1 when you square it is important. This is not x squared plus 1. This is x squared plus 2x plus 1. Okay. All right.